Hey everybody, today we're going to be looking at 4.6 inverses of functions. So inverses of functions actually aren't too bad. Really, it's just switching variables and solving for one of the variables. And that's really what it comes down to. We're going to look at it from a graphical approach and an algebraic approach today. So that being said, let's take a look at how to solve for a variable. Again, this should be a skill that you already know, but let's just double check. So for example, on this first one here, I want to solve for y on all of these. So since I'm solving for y, the goal is to get everything away from y. So I'm going to move this 3x over by subtracting. I now have negative y equals negative 3x plus 4. I still have that negative I need to deal with, so I'm going to divide by negative 1 on both sides. On this side, this is a good ACT trick that they like to do. Really what this does is it's going to change these two signs because that's what it did over here, right? I took a negative, negative gave me a positive. So now I've got y is equal to 3x minus 4. Was negative, became a positive, positive became a negative. Um, and really that's it. Like that's what we're going to be doing for this section. Just doing another quick one real quick. I've got 3x minus 2y equals 10. Again, we're going to move that 3x over, 3x. I'm going to have negative 2y, negative 3x plus 10. Again, negative 2, negative 2. Now in this case, because I have that negative 2, I really don't need to try to combine those. I only really need to do it here because it's a 1. Because dividing by just positive 1 wouldn't really do anything, and the negative 1, all it really does is change those signs. So these cancel. I'm left with y equals negative 3x plus 10 over negative 2. Okay, and again, that's pretty much the section. If you can do that, you're going to be fine. Um, now, we want to take a look at these and we want to take a look at what these look like because that's going to be important for what we're about to do. So go ahead and head over to Desmos. And if you need to pause, go ahead and pause. But we're going to head over to Desmos. We're going to look at these graphically first. You're going to head to Desmos, go to the graphing part, and then we're just going to plug these equations in. So for my first one, sorry, there we go. I've got 4x plus 3. So y is equal to 4x plus 3. And then I've got y is equal to, x minus 3 over 4. 3 over 4. And what I see is if I drew a line through y is equal to x, but these two things are mirror images of each other. If I folded the top half of this red line over, it would match up with this blue line. Same with the bottom. Okay, so folding these things over that middle line, that y equals x line, they're equivalent. So when that's the case, we call these inverses. So looking at a couple more, again, we're gonna look at them over the y equals x. So for this one, x cubed plus 1, so x cubed plus 1. And for this one, we're going to do the cube root. So remember for cube root, ooh, that's in the way. Good. There we go. For cube root, we want to come down here. We want to go to functions, miscellaneous, and then this n root. I put it in the wrong spot. Sorry. Hold on one second. Here we go. Functions, miscellaneous, root, cube root of x minus 1, I believe. Yep. And we can see here, right, that it folds over that y equals x line. So that's how we know a function is an inverse of another function. So that being said, how do we find these inverses? What do we do to get these inverses? Okay. Now I do need to be careful, and actually I do need to do one more of these. I do need to be careful. If you notice here, I've got some restrictions. And the reason I have those restrictions is let's do this. So we've got x, square root of x minus 3 under, and then we've also got x squared plus 3. Okay, and it kind of looks like we're okay if I took this left side off, right? Because if I just had this right side, it would fold down. But that left side, I don't have that left side of the vertex down here. So that's why we have the restriction on here. Let's see if I can do this right. So x needs to be greater than, I think it's this, x greater than 0. Nope. But that's why we only look at x greater than 0. So we start at 0 and we go to the right. Okay, so that's why it has that restriction there. We'll look at some of those, don't worry, and how to determine those. But the idea here is that, again, we have this line going through x, y equals x, and it's going to mirror on the other side. And that's always going to be true. So it'll mirror on the other side. Okay, now, how do we actually do this? That's the important part here. So first thing we need to do is switch the signs. Okay, so what we're going to do, or switch the variables. What we're going to do is we're going to start with y equals 2x plus 3. I'm going to switch x and y. That's all I'm going to do. I'm just going to change where x is. I'm going to put a y. Where y is, I'm going to put an x. So x equals 2y plus 3. And then I'm going to solve for y. So I'm going to move this 3 over. So x minus 3. Sorry, minus 3, minus 3. So let me not skip steps. 2y. Divide by 2. Divide by 2. I've got x minus 3 over 2 equals y. Okay. Now it says here, what is the input when the output is -7? And they're looking at the original function. Okay. Remember, input is x, and then the output is what I'm equal to. Well, what we're doing when we do an inverse is that allows us to just put in the output to find the input. Normally, what we would do is we would say -7 is equal to 2x plus 3, and then solve for x. Well, now I know what the inverse is, so I can take this -7 and plug it into x now. So -7 minus 3 over 2, -10 over 2, -5. And I would have got the same thing here, right? -3 minus 3, -10, 2x, divided by 2, divided by 2, x is still going to be -5. So it doesn't matter which way I do it, I'm still going to get the same thing. The nice thing here, though, is if I need to do a lot of outputs, it's going to be a lot faster to have this new equation. And really, that's kind of it. Like, you change the y and the x, you solve for the new y, and that's your solution. Now, I do need to be careful if I have like a square root, but that's not bad. Okay, so again, y is equal to x minus 2. Switch my x and y. Plus 2 plus 2, x plus 2 is equal to y. Here's my new equation. I'm going to plug in 2. 2 plus 2 is 4. Okay, and that's just doing the same thing. Now, this is one, again, I need to be kind of careful. So if I think about this graphically for a second, I've got x squared. X squared looks like this. But it's telling me x needs to be greater than 0. Or greater than or equal to 0. So really this left side I'm not going to use. I'm going to start at 0 and then go up. Okay. Now for the inverse, again, it's going to cut right here, right? And then in the inverse is going to look like this. And that should look very familiar. This is my square root function, which if I solve this, y equals x squared, switch my y and x, solve for y, and there we go. Now the question comes up, well, why am I not using the negative side here? And that's because of whether or not it's a function. If I use the positive and the negative, it's no longer a function. So when we're graphing, we usually only use the positive. We don't want to use that negative. Okay, and this is where that's showing. So if we're talking, so we talk about the vertical line test. So going back just real quick, the vertical line test says that I can drop a line anywhere and it will touch at most once. This is a function. Over here, it doesn't touch. That's fine. It can only touch at most once. So I can touch 0 times. That's fine. But if I had that plus minus, right, I'm now touching twice. This is no longer a function. Okay, so what the horizontal line test does is it tells us, hey, if you can't do the same thing with a horizontal line, it's not, the inverse is not a function. So looking back at these, right, that first one I drew, right, the original is a function, but the inverse of this would not be, because the inverse of this would be this, and it is not a function. So what the horizontal line test does is it shows us whether the inverse is a function. The vertical line test shows us if that function is a function. Okay, so we got, again, same thing. I'm going to change the x and y's. Or actually, sorry, this one asked me to graph it first. So I'm going to graph, so 2x or 2x cubed plus 1, because it wants us to think about it first. So y is equal to 2x cubed plus 1. And again, looking at this guy, it does look like I'm vertically okay, vertically and horizontally okay. If I zoom out a little bit, yep, still fine. Okay, so going back, yes, it is a function. Yes, the inverse is going to be a function because I passed that horizontal line test. Let's find the inverse. Y is equal to 2x cubed plus 1. X, y, just change them. Solve for y, minus 1, minus 1. X minus 1 is equal to 2y cubed. Divide by 2, divide by 2. X minus 1, 2 is equal to y cubed. Cube root, cube root. Y is equal to the cube root x minus 1 over 2. And there is my inverse. Okay, so same thing. If I go over and do this one, 2x minus square root of x minus 3, so 2 square root of x minus 3. Okay, so looking good for the vertical and the horizontal, but let's just double check, zoom out. Yep, still good. Okay, so I'm probably okay, but let's go and do the inverse and just double check. So again, the original looks something like this. So we're going to do 2x, square root of x minus 3 equal y. Switch x and y. 2 y minus 3 equal x. Divide by 2, divide by 2. Square root of y minus 3, x over 2. Squared, squared, y minus 3, x over 2 quantity squared, plus 3, plus 3. So then y is equal to x over 2 quantity squared plus 3. Okay, now hold up a second. Let's look and see what this looks like. So I've got y is equal to the, x divided by 2 quantity squared plus 3. Well, again, I ran into this problem now where half of it kind of works. So I need to be careful here, and I need to say that x needs to be greater than or equal to 0. Because if I exclude that left side, and sorry, let me actually redraw this so it's a little bit better, more accurate. Just realized it's actually coming out here. Sorry about that. So again, if I have that the whole thing, it's not a good representation. But if I only have that right side starting at 0, then it does fold over for me like I want it to. So sometimes you will need to do that. Almost always, it's pretty much when you have a square root, either in your answer as the inverse or what you started with. Okay. Again, this is just more of the same. So for this one, verify that these things are inverses. Just check both ways. Okay, and you do want to check both ways. It's important you check both ways. But I start with y is equal to 3x minus 1 plus 1 plus 1, y plus 1 equals 3x. Divide by 3, divide by 3. I get, oh, sorry, going way too fast. I apologize. We need to switch x and y first. There we go, that's better. Okay, so plus 1, x plus 1, 3x or 3y. Divide by 3, x plus 1 over 3 is equal to y, which is what I have. Okay, now it is again important that you go backwards, and specifically if you have a squared or a square root, because those ones always don't go back and forth, especially if there's no restrictions given. That's a good clue is if you have a squared or a square root and there's no restrictions given. So y equal x plus 1 over 3. Switch x and y this time. Multiply by 3 on both sides. 3x equals y plus 1 minus 1 minus 1. 3x minus 1 is equal to y, okay, which is what I would have started with. So that's just how you check, okay? It's not a big deal, just an extra step. You have to do it twice, basically. And really, that's it. Again, these are just checking to see if they're inverses or not. If you don't get the same thing going backwards, that's when you know they're not inverses. And really, again, that's it. One thing to watch out for is on Desmos today, you are going to have a couple where you need to graph them. Okay. Just use the tool. If you get stuck, make sure you email me. Again, please make sure you're reaching out to me if you need extra help. This is not too bad of a section. Again, what it comes down to is swapping X and Y, solving for Y. That's really what it comes down to. Again, if you get stuck, make sure you're stopping in for that RTI time or before and after school tutoring. And I will see you guys next time.